How to study exoplanets, Webb, and challenges. Thousands of exoplanets have been discovered, but there's still a lot we don't know about these fascinating worlds. How did these planets form? Can planets around red dwarf stars hold an atmosphere in the face of violent stellar flares? What can these worlds tell us about our own solar system? The James Webb Space Telescope is helping answer these questions by observing some of the most interesting exoplanets astronomers have identified so far. With its large mirror, high degree of infrared sensitivity, and spectroscopic capabilities, Webb can explore a greater diversity of molecular components of an exoplanet's atmosphere than ever before. From finding sulfur dioxide present in the atmosphere of gas giant exoplanet WASP 39b, to noting the absence of a significant atmosphere on TRAPPIST-1b, a rocky exoplanet somewhat larger than Earth, Webb is advancing the field of exoplanet science. Studying these distant worlds requires identifying innovative tools and methods to navigate challenging conditions. For example, we can use an instrument called a coronagraph to block out some of the bright starlight and reveal exoplanets if they are far away enough from their host stars. Even with current telescope technology, limitations still exist, such as the inability to directly image Earth-like exoplanets because they're too faint and typically too close to their host stars. Any imaged exoplanet will resemble a tiny pinprick of light, which is why every detailed image of an exoplanet you see is actually an artist's concept. To study worlds where direct imaging is not feasible, scientists use other methods, like noting the light from a star that has passed through an exoplanet's atmosphere, also known as transit spectroscopy. This can be a time-consuming endeavor as it is dependent on the exoplanet's orbital path and often entails multiple transits to piece together the planet's atmospheric composition. Multiple transits also build a more reliable data set that helps control for star spots, flares, and other unexpected activity from the exoplanet's host star. Although studying other worlds is challenging, the data Webb gathers is helping us answer big questions. And Webb is just getting started.